Welcome to Engineering Scale Models. I'm Jason, your host, and I do models and electronics. Today we're looking at the Code Crack game. We added some memory to it. Let's take a look here. This is going to be a brief overview of what I did. If you watch the other videos, you will see how the first part of this with the actual rotary encoder going through a inverter with the Smith trigger feeds into a... I have to look at this chip. I don't remember them off the top of my head. An LS 164, that is a serial in, parallel out, and by turning the thing different ways you can try to match the code that is on here, and then this code can be set by these dip switches, but currently it is working off some new memory I installed. So I installed some LS189. These are 4 address 4-bit memories. They each have 4 addresses, and they each store 4 bytes. So I have 2 of them to get a 16 to get 8 bits out and 16 different levels. So 16 bytes. Yeah, 16 bytes. And then they're going, this sends out an inverted output, so they're going through some LSO4s, 74 LSO4 inverters. I have a manual addressing unit here. I also have it running on the clock pulse here. That is eventually going to get put into this button on the rotary encoder to advance the level, but this is where I got now. I got this all set up. So as you can see here, as if you look at the master code here, and as I scroll through the letters, the levels up to 16, the master code changes every time. So there's 16 different levels, starts at level 0, and you match the code, hit the button, match the code, hit the button. There's going to be a timer circuit in the future, but this is where we are now. I had a lot of issues working out the RAM and getting the inputs. It's why the wires aren't routed super neatly, because I was having a bunch of issues. I was trying to run too many LED displays, but this seems to work good. This is volatile memory, so if I turn the unit off, it will wipe everything in memory and go to random values. So this will be upgraded to an EEPROM. I just wanted to test the concept of this game. This is going over in steps. It's to teach my son that there's not a need for microcontrollers. You can do it with old school logic. So that's where we're at. So it's a pretty cool system. You know, if I wanted to match this code, let me clear it. So 1 and then 2 blanks, a 1 and 3 blanks and a 1. So, you know, I matched that. So now I would go to the next level, and then I have 1 solid, 2 blanks, solid blank, solid blank, solid. So there, I matched that. Next level. So I have a solid, 2 blanks, solid, blank, solid, solid, blank. So there, I matched that. Go to the next level. Then I have a solid, blank, solid, solid, blank, 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 solid. So there we go. So I matched that code, and then you can go through all 16 levels. I know it's hard to see because of how I've had to run everything. I've been having a lot of issues with jumpers, but I'm going to route all these wires nice and neat so it's stuck on the breadboard. It's going to be a rat nest, but I don't know if I'm going to upgrade to the EEPROM in the next video, or if I'm going to do the add the level progression system where you click the button and it moves the level for you. Also, I was thinking about adding some comparators to compare this with this, and if it matches, a green light lights up. If it doesn't match, it shows a red light. So I'm not sure the direction I'm going to go next. You'll have to stay tuned for the next video on what's going to happen next. This is a cool little project I work on. I don't work on it all the time. I try to do one day a week on it, but it hasn't been like that. A lot of switches need to be fixed and things like that. But this is some basic digital logic. I mean, this is transistor level logic, and it's actually TTL logic, transistor to transistor logic. And understanding how simple logic circuits work and using them to do what you need it to do is a great way to learn how electronics work, because all digital electronics are based on logic circuits, and most of those chips and basically all IC chips are just consisting of tons and tons of transistors. So understanding how basic simple gates work and what makes up a gate, and I have a whole series on digital logic. I have an series that talks about these LS chips. There'll be more videos coming out on that soon, but this is, a fun little project. If you want to do it, send me a message. Here is the links to my social media. You can send me an email, and I'll get you a parts list, and then you guys can put it together. And then as I work on it, I will update the parts list. You can also visit me on Patreon, where I have some stuff up there for no need to sign up. You just go there and download the file, and you're good to go. Some switch documents. I'm also going to put some stuff about this on there in a few weeks. So thank you so much for watching. I know it's a short video, but hopefully you liked it, and this is more of an update anyways. Thank you so much, and have a great day.